Good morning students. Hello again. Now today we are going to discuss the second part of general circulation of atmosphere. So before starting the next part, I am going to give you the, you can say, rapid revision of the last lecture, that we have seen the whole earth is divided in different temperature belts depending upon the angle of sun rays which are coming to the earth, in which 30 to 30 torrid zone, then after 30 to 60 temperate, and then after frigid zone. And we latitudinally divided the earth in different temperature belts. Apart from that, what we saw that globally the temperature distribution which is latitudinally present, apart from that the local factors are also responsible and they govern the temperature of any place, like the altitude of the place, or you can say location from sea, then after the ocean currents along them, then prevailing winds, vegetative cover and the slope aspect. So what we saw that the local factors basically they, you can say, reduce the effect of latitudinal location of any place. Now after that we are going to see today the pressure creation on earth's surface, then after the pressure belts, wind belt and the general circulation. So if we talk about the pressure gradient, means the atmospheric pressure, or you can say the barometric pressure over the earth's surface. So the pressure on earth's surface is formed in two ways, that is thermal induced pressure and the dynamic pressure. Dynamic pressure is also known as mechanical pressure. Now the question comes, what is the difference between the mechanical pressure and the thermal pressure? So basically in thermal pressure, the solely governing factor is temperature. Means according to the temperature, the pressure of the place will be governed, but in mechanical or dynamic, what we will see that the temperature is not putting any effect on the pressure of that place, but rather the movement of air, or you can say wind, is, you can say, making the pressure. So first we are going to see the thermal pressure, how it is formed. Suppose any place is having high temperature. Now when the place will have high temperature, the air near to the surface, we know that it will be heated up by the process of conduction, and after heating the air will expand and become lighter, and what will happen, it will start moving up. Now when the air will rise, the vertical movement of air, it will go till the extent of tropopause as we know, and after tropopause it will diverge. So the question comes, why it is going to diverge? So see here, so when the air present on the surface will ascend, then the surface will have air deficit and it will create low pressure, and as the air is going and accumulating over the tropopause, it will create surplus, and air surplus means high pressure in upper air, mind it. Now on some other place the temperature is low. When the temperature will be low, the air will become cold and heavier. Now the heavier air will start sinking, or you can say it will descend, and when it will descend, it will create a air surplus area over the surface. Now this air surplus will create high pressure on the surface, and as the air has moved down in upper air over tropopause, air deficit will be there and it will create low pressure. And we know that air moves in the horizontal pressure difference in the form of wind from high pressure to low pressure. Now, as you can see, a conveyor belt has been created, and this conveyor belt is only known as convectional current, means the movement of air due to you can say temperature. Now, here the pressure and the temperature over the surface, mind it, you have to consider only the pressure which is being created on the earth surface. Okay, higher the temperature, lower the pressure, lower the temperature, higher the pressure. Okay, but in dynamic what happens? In dynamic, suppose over a place from two directions the wind is coming. Okay, as you all know, the surrounding us is air, mixture of gases, and when the air will move horizontally, it will be considered as wind. So when from two directions wind will come over the surface, it will collide and it will start rising up, as because it can't go inside the earth crust. So when the wind will collide and rise up, it will become air and it will ascend. Again it is going to ascend till tropopause. When the air will ascend till tropopause, the surface will experience low pressure, means deficit, and due to accumulation over tropopause, surplus and high pressure. On the other place, in upper air, from two directions the wind will come, it will collide, and as we know that the wind or air can't move beyond tropopause, so it will sink down, and when it will sink down, it will create air surplus on surface, means high pressure, and deficit in upper air, means low pressure. Now again the wind will move in horizontal pressure difference from high pressure to low pressure. Again the conveyor belt has been created, but here what is the temperature? No matter, means the place is experiencing low pressure, but the temperature can be in minus. Okay, here the pressure is high, but the temperature can remain plus. Here the pressure is being created due to the movement of wind, mind it. Now the question which has came in your mind, what is that? Sir, from where these two winds on the surface are coming, and from where these two winds in upper air are coming? There must be some source, so don't worry, we will come to that also. But before that, remember few things in your life. Ascending air always from surface to upper atmosphere will create low pressure on surface. Then after, sinking air or descending air will create high pressure on surface, and air move in horizontal pressure difference from high pressure to low pressure. Second thing, always remember, ascending air gives moisture. Why? When the air will ascend, the process of condensation will take place due to lapse rate, as we all know, we have seen in the structure of atmosphere, and when the condensation will take place, the vapor will turn into either water droplets or ice crystals, and they will fall in the form of precipitation. Can be snowfall, rain, drizzle, sleet, hail, anything. And sinking air takes moisture. Why? Because first thing, it is cold and dry. Second thing, when it will move down, the temperature will increase. Basically, it will become warm and dry due to friction. So, it will take the moisture. And the most important thing is that the sinking air gives a brilliant sunshine, or you can say cloudless sky. So, remember all these three things, or you can say four things: ascending, low pressure on surface; descending, high pressure on surface; wind move from high pressure to low pressure; and the ascending air gives moisture and descending air takes moisture. Now, due to this process, the atmospheric pressure is created, or the air pressure is created on the surface. Now, the imaginary lines are basically those lines which connect the pressure, the places with equal barometric pressure are considered as isobar. Basically, this is a type of isopleth. Iso means equal and pleth means phenomena. Means those lines which join the places with equal phenomena, like equal pressure, isobar; equal height, isoheight; or equal depth, isoneph; equal salinity, isohaline. Then after isochalge, isobrant, all these. So, time, cloud cover, equal rainfall, or seismic activities, isoseismic lines, all these in this isobar. And most important thing, the difference between isobar. Okay. So, the pressure difference of the places and the normal barometric pressure in atmosphere is considered as 1013 millibar. Okay. And if the isobars are widely spaced, means there is a large gap between the isobar, then the pressure gradient is less. But if the isobar are closely spaced, then the pressure gradient is steep. Always mind it. How? Suppose this is 1010 millibar, 1005 millibar, 1000 millibar, 995 millibar. Means the pressure is decreasing in this way. So, first thing, the pressure gradient is from south to north or from bottom to top, and is normal, or you can say decreasing with a regular interval. But suppose if the isobars are closely spaced, again I am telling you, so instead of this, if the isobar will be 1010, 1005, 1000, then 995, 990, then 985, 980. Now the pressure gradient will become steep. Okay, and we know that pressure gradient determines the movement of air or the wind from high pressure towards low pressure. Means due to the formation of pressure, the movement of wind take place. Now, if we talk about the wind, the factors responsible for the movement of wind. So, there are few factors which are responsible, like the first factor, which is responsible for the movement of wind is pressure gradient force. Okay, first thing. And pressure gradient and wind speed is directly proportional, inversely proportional. I am repeating it once again. Pressure gradient and wind speed is basically directly proportional. More the pressure gradient, more the speed, less the pressure gradient, less the speed. Means if the pressure is decreasing on a regular interval over a long distance, then the speed will be very less. So the gradient is less. But if the pressure is changing on few meters and rapidly it is changing, then this wind speed will be high. First thing. Second thing, as the pressure gradient is being you can say demonstrated with the help of isobar. So the gap between the isobar is representing the pressure gradient. So isobar gap and the pressure gradient is opposite, inverse. How? More the gap, less the gradient. Less the gap, more the gradient. Means the gapping between the isobar will determine the steepness of the pressure. So gap will be more, so the pressure will be less, gap will be less, pressure will be more. Now if we talk about the isobar relationship and the wind speed relationship, so less the gap, more speed, more gap, less speed. Why? Because pressure gradient and wind is directly, pressure gradient and isobar are inversely. So wind will be also inversely to the isobar. More the gap, less the speed, less the gap, more the speed. So first factor is pressure gradient force, which is governing the movement of wind. Second is the frictional force. Friction means obstruction in the way of wind. So more the friction, less the speed, less the friction, more the speed. Like we used to drive car or bike on road. So we apply the brake, and brake are nothing but the friction with the wheels. So when we will apply more brake, means more friction, the speed will be less. And when we are going to apply less brake, less friction, the speed will be more. So the speed and the you can say friction are also inversely. More friction, less speed, less friction, more speed. The third factor which determine the movement of wind is Coriolis force. Now the question comes, what is Coriolis force? So basically this is not a force, but rather it is a phenomena or event which is exerted on any freely moving object on earth, basically. And as because this was given by Sir Coriolis, Gaspard de Coriolis, in the decade of 1840s, it is considered as Coriolis force. Now the question comes, what is Coriolis force? So he stated that any freely moving object, even wind or any freely moving object, will turn towards their right of their path in northern hemisphere and towards left of their path in southern hemisphere. Repeating it once again, any freely moving object will turn towards right of their path in northern hemisphere and towards of their path in southern hemisphere. Now the question comes, sir, how? So let's have a look. Suppose I am giving you 4 directions. basically. See, this is north and this is south. So, if the direction of the object or wind will be in this manner in northern hemisphere, so it will get deflected towards right of its path. Okay, if it will be this, again right, in this direction right, and in this direction right. Okay, in southern hemisphere it will be deflected towards left of their respective direction. Suppose if I am going to throw you also, you will get deflected towards right because you are sitting in northern hemisphere. Okay, this means if the wind is moving like this in northern hemisphere and the pressure gradient is decreasing like this, it will get deflected towards right of its path and the original direction will be this one. Simple. Rather than this. So, these are the three major factors which affect the movement of wind. Okay, what is that? Pressure gradient force, Coriolis force and frictional force. Second thing, the Coriolis force applicable or the, you can say, the deflection of object is basically 0 over equator, means Coriolis force is almost negligible on equator, and as we move from equator towards pole, the Coriolis force deflection increases and maximum it is over the poles. How? As because equator is having the maximum area, so the deflection will be very less or negligible, but as we are moving towards the pole, the area is shrinking but the matter is the same, so the deflection will be more. Okay. Second thing, in value, Coriolis force is 0 on equator and maximum 1 on poles. Okay. Then after, the deflection of object or the degree of deflection on the basis of speed, if we say, if the speed of the object will be more, then the application of Coriolis force will be also more. And if the speed of the object will be less, the deflection of the object or the application of the Coriolis force over that object will be less. Means the speed also determines the deflection of the object. So these are the few parameters of Coriolis force. Now we will see the, you can say, relationship between the pressure gradient force, Coriolis force, isobars and the wind direction. So let's have a look. We have already seen the relationship between the isobar and the pressure gradient force. Now these are the isobars. If we notice the pressure gradient, so the pressure gradient is basically decreasing in this direction. Okay. Now the wind will move also, but when the wind will move, what will happen? Coriolis force will be applied. Suppose it is in northern hemisphere, so the wind will get deflected towards right of its path. If it will be southern hemisphere, it will be deflected towards left of its path. But right now we are considering northern hemisphere. Okay. So if we talk the pressure gradient force and wind direction, so both are perpendicular to each other. Okay, as you can see, if we talk isobar and wind direction, they are parallel to each other. Okay, isobar and pressure gradient force again perpendicular. Coriolis force and pressure gradient force is perpendicular because either right or left. Coriolis force and wind direction, they are parallel to each other. Clear? And you have to remember this because it is clearly written in chapter number 9 or 10, atmospheric circulation, about the relationship between the pressure gradient force, isobar, pressure gradient force, wind direction, pressure gradient force and Coriolis force. Okay. So Coriolis force is going to be applied perpendicular to pressure gradient and parallel to wind direction. Wind direction will be perpendicular to the, you can say, pressure gradient and parallel to isobars. Isobar will be perpendicular to the pressure gradient. So always remember this part. Now we have seen how the pressure is formed on Earth's surface, how the movement of wind take place. On the basis of this only, we are going to see the atmospheric circulation which is formed on Earth due to the differential heating on different latitudes along with the movement of wind and due to application of Coriolis force. So let's have a look. see on the board, this is the surface on which we are present, or basically we live on the surface of Earth, and this is the actual surface on which we are. So equator, on equator temperature is high throughout the year. Now when the temperature will be high throughout the year, the pressure gradient will be low. Higher the temperature, lower the pressure. Means pressure on equator is basically thermally induced. Polar areas are frigid zone. So temperature will be low and the pressure will be high. Means these two pressure belts also are thermal induced. Means equatorial low pressure belt and polar high pressure belt. Now suppose this is equator and the both ends are pole. So on equator, when the air is being heated up, it will become lighter and start moving up in the atmosphere. Now when the air will move up in the atmosphere, it will reach till tropopause, as we know, and after reaching tropopause it will create high pressure because on the surface low pressure is there. Right now we saw, and on the poles over the surface high pressure is there. So in upper atmosphere there will be low pressure. So when the air will reach the tropopause of equatorial belt, it will create high and move towards the polar low pressure which are created in the upper atmosphere. Means either they are going to deflect towards north or towards south. Now when they will move, basically the air which is being lifted up over the equator is over the source region. But when they will leave the source region, their energy will decrease and basically they will move away from their source region. So what will happen? They will become unable to move to pole and rather they will start sinking on 30-35 degree latitude in both the hemisphere. And when they will sink, if you remember, the sinking air over surface creates which pressure? So it is high pressure. Now if you notice, the temperature on 30-35 degree is high, but the pressure is also high. Means the pressure over this surface is being determined by the movement of wind. So it is dynamic high pressure. Means 2 dynamic high pressure also we got along with the 3 thermal. Now when the wind will sink and you can say sit on 30-35 degree latitude, it will bifurcate in 2 opposite direction, one towards equator and one towards pole. Now when this wind will move, we know that Coriolis force will be applied, and due to application of Coriolis force, the wind which is moving in northern hemisphere towards equator will be deflected towards right of their original path and they will become like this. And the wind which are moving towards pole, they will also get deflected towards right and their direction will become like this. In southern hemisphere, they will be deflected towards left of their path, and here also towards left of their path. Means 2 more, or we can say 3 wind belts, or if we separate 4 separate wind belts we got, and the name of wind is given traditionally from the direction it is coming, means north, south, east, west, northeast. So these are known as north-east trade winds, and this one is southeast. So southeast trade wind. Southeast and northeast we got, but the question comes, why we consider them as trade winds? So basically, these winds were used for trade. During the colonial time, when the traders start moving from higher latitudes to lower latitudes, by that time there was no such invention of motors and the machines. So the boats were sailed with the help of wind. Now, wind used to push the, you can say, sails, and the boat moves, and the main purpose was trade. That's why they are considered as trade winds. And northeast direction northeast, southeast direction southeast. So we got one wind belt also, collective trade wind belt. This direction is from west, as because the Coriolis force application will be more, and instead of 45 degree, more than 45 degree deflection. So the wind which move from west are known as westerlies. Means one westerly is belt up and one westerly is belt down. We again got, along with 5 pressure belts, 3 wind belts we got. Now, over the poles, due to high pressure, the wind is cold and heavy and sitting on the polar surface. And we know the earth is rotating, and the rotational speed of earth is 1600 km per hour on equator, 1400 per hour on 30 degree, 900 on 60 degree, and 0 km per hour on poles. Now the question comes, why? So basically the area covering during the same time is decreasing or increasing, so the speed will increase or decrease. Like the places which are sitting on equator or the atmosphere have to cover the maximum distance because the area on equator is maximum. The time is 24 hours, but as we move from equator towards pole, the area is shrinking, but the time is same 24 hours. So those who have to cover the longer distance in same time will have to run fast, and those who have to cover the same less distance in the same time, they will run slow. Like you have noticed, the running tracks in the field or stadium, the inner one track, the person who is running on inner track will move slower, and the person who is moving on the outermost track will have to move faster to cover the distance in same time. So this happens over here. So as the wind air is sitting on pole due to high pressure, but freely sitting object, and earth is rotating. So due to rotational speed of earth, or due to rotation of earth and the freely sitting nature of the air is deflected out or thrown out from the poles. As because the force which is exerted over here is centrifugal force, or you can say force of inertia, which states that any freely sitting object will be thrown out of its original place on a rotating disc. Means the air from the polar areas will be thrown inside, means towards the lower latitudes, and they will, when they will move, the Coriolis force application will be there, and we know Coriolis force is maximum on poles. So instead of 45 or 60 degree, they are going to deflect complete 90 degree from their original path, either in left or right, and they will start moving from east. That's why if someone asks you that the wind in polar areas move from which direction, so always east, and when they will move from east, they will be considered as easterlies, and due to location in polar area, they are known as polar easterlies. Now we got the two more wind belts, one in northern hemisphere and one in southern hemisphere. But one pressure belt is still left. Let's have a look. Westerlies and polar easterlies. When westerlies and polar easterlies will meet between 55 to 60 degree latitude, if you remember the dynamic pressure belt, when the winds will come from two opposite directions, they will move up. And when they will move up, the pressure which is going to be created will be low. This means another pressure belt has been formed due to the movement of wind, and that is subpolar low pressure belt. And if you notice, the temperature over this latitude remains in minus, means the temperature is not the governing factor for the movement of wind, or basically for the creation of pressure. Now again, when they will reach to the tropopause, they will become high, and over here as the air is sinking, it is low. So one part will move this way, means in upper atmosphere towards the lower latitude, and the one part will move in the upper atmosphere towards the pole. When they will reach pole, they will become cold, and due to cold nature, they will sink, and when they will sink, they will create high pressure. Over here, when they are meeting, again, if you remember in dynamic, the wind in upper air is coming from two opposite directions and meeting and sinking. Now you recognized, or you got the creation of dynamic pressure, either low or high. Now when they will sink, again they will create high pressure, which is subtropical high. Now after sinking on pole, they will move in this direction. Let me give this a different color. Polar easterlies, westerlies, southeast trade winds, northeast trade winds, and westerlies. Now if you recognize, three separate sails has been formed in the northern hemisphere and 3 in southern hemisphere. The initial 2 was given by Sir George Hadley, due to which it is considered as Hadley sail. then after subpolar cell or Farrell cell, because it was given by Farrell, and polar cell. In the bottom, same. Now you might be thinking that all are given in the same time. No. Basically, this is a phase-wise development or discovery. Initially, the general circulation was not the, you can say, 3-cell dimension or meridional circulation, but rather it was single cell, means it has developed with phases. First, it was given by Hadley, 1-cell model, means directly to pole and pole to, you can say, equator. Then after, the 2-cell model came. Then after, the 3-cell model came. So it is a phase-wise development over a centuries. Today we are getting it like this, the tricellular model or meridional circulation, means just copy which is in north, just copy in south. Now let me give you some more terms, like the westerlies which you are seeing. We have seen right now that the speed of wind is determined due to friction. So in northern hemisphere, if we see between 35 to 60, many land masses are there, North America, Europe, Asia. So the obstruction will be more and the wind speed will be less. But if we notice in southern hemisphere and you give a look on the, you can say, world map or globe, beyond 40 degrees south latitude, there is no such landmass, only oceans. So the speed of westerlies increases in southern hemisphere, and due to which the westerlies are known by different names, like on 40 degrees south, roaring 40s, 50 degree furious 50s, and 60 degrees south, screaming 60s, only in southern hemisphere. Then after, the region between 5 degree north to 5 degree south is considered as doldrum, means the region nearby equator where temperature is high, pressure is low, and calm weather condition, means no wind belt, and that situation is considered as doldrum. But as the northeast and southeast trade winds are meeting in the tropical area, so the region between 10 degree north to 10 degree south is considered as ITCZ or thermal equator or equatorial trough, intertropical convergence zone. Why thermal equator? The place nearby equator where temperature is high, and equatorial trough means pressure is low, and it is never constant, or you can say in a straight line, but rather it used to fluctuate according to season, according to migration of sun and distribution of land and sea, due to the difference in specific heat. So when the sun will migrate in northern hemisphere, the ITCZ will shift north, and when the sun will move in southern hemisphere, the ITCZ will move south. And the another important latitude, 30 to 35 degree, north and south latitudes are considered as horse latitudes. Why horse latitude? As because when the traders used to move from Europe towards the lower latitudes, the sinking wind on 30-35 degree latitudes, they increases the pressure on the boats, and due to increased pressure, the ships start sinking. So to prevent the ship from sinking, what they used to do, they throw the horses into sea, means due to throwing of horses in sea, 30-35 degree latitudes in the both hemisphere are known as horse latitudes. So basically these are the terminologies and the name of the westerlies, trade winds, polar easterlies, Hadley cell, all these, equatorial low pressure, subtropical high, polar low and polar high. So this is general circulation. In the coming lecture we will see, due to the less friction in upper atmosphere, the winds take a high speed which are considered as jet streams, and the upper air circulation is known as geostrophic winds, and when they take a wavy pattern, they are considered as Rossby waves. Then after, what is polar vortex, all these things. So we will meet in the next class with a more interesting topic. Till then, thank you. Have a nice day.